Okay, this is exam 2 for physics 101. A projectile is launched with an initial velocity of 100 meters per second at 30 degrees off the angle of horizontal. What is the horizontal velocity of the projectile at the highest point? So we're looking at the horizontal velocity up here, that's Vx, and I just want to recognize that it's equal to V naught x. So I really just need to find V naught x. That's going to be V naught, which is 100, times the cosine of 30. And that's equal to 86.6. So D. You kick a soccer ball at an angle of 30 degrees. It travels a horizontal distance of 8.67 meters in 1 second. What is the magnitude of the ball's initial velocity? So I have x is 8.67, t is 1 second, and I want to know, I know theta is 30 degrees. I want to know what is the magnitude of the ball's initial velocity. Well, x is equal to Vx times t. And so I can solve now for Vx. It's just going to be x divided by t, and that's going to be 8.67 over 1. So it's 8.67 meters per second. But I want to know the initial velocity. That's not the answer. Instead, I want to know what V naught is. I need to recognize that Vx is equal to V naught times the cosine of theta. So Vx, which is 8.67, is equal to V naught times the cosine of 30. And so solving that, I get V naught equals to 10 meters per second. So D. Projectile is launched from ground level over level ground at an angle of 30 degrees above the horizontal. Speed is 100 meters per second. Neglecting air resistance, at what horizontal distance will the projectile land? Okay, so I need to first find the time. I have this object is traveling like this. I can find the time in a couple different ways. I'll find it by saying that Vy at the top is equal to 0. And so Vy equals to V naught y plus Ayt. I'll call this t top. So that's 0 equals 100 sine of 30 minus 10 times t top. So let's see, this is t equals to 5 seconds. So it takes 5 seconds to get there. That means it takes 10 seconds to get over here. So x is equal to Vx times t. That's equal to V naught cosine theta times t, which is 100 cosine 30 times 10. Uh, 866 are 900 meters. So B is 3. Spring-loaded gun shoots a ball in the horizontal direction with a height of 45 meters, has an initial velocity of 10 meters per second. At what distance does it land from the ball? Or does the ball land? So looks like this. This is like what we did in lab. It has a height of 45 meters. So first I want to find my time. I say y equals V naught y t plus 1/2 ay t squared. That's a t. And then I have y is negative 45. V naught y is 0 because the velocity is initially only in the horizontal direction. Equals 1/2 of negative 10 or negative 5 times t squared. So t is equal to 3 seconds. I want to know what distance does it land? Well, it travels at 10 meters per second times 3 seconds. So it must be 30 meters. D is 4. 2 shells are fired simultaneously. Which target does it hit first? It hits this one first because the y displacement is less, so it has less hang time. Fire a projectile over ground level and over level ground. If you double the horizontal component of the initial velocity, how much more time would it take for a projectile to hit the ground? If you double the horizontal component, that does not affect the time. It would only if you change the y component of the velocity of the vertical. So let's see. The time to reach the ground would remain the same since the vertical component of the velocity also gets doubled. Okay, that's not true. because we're not doubling the vertical component. The time to reach the ground would be doubled since the horizontal component of the velocity is doubled. That's not true. That would remain the same since the vertical component is unchanged. So that is the answer. And then D is not true either. What is true when the height of a projectile is at its maximum? Vy is equal to 0. None of these other things are true. For two-dimensional motion of a projectile that begins and ends at the same height, all the following apply except for which of these? All right, the time for the projectile to ascend and descend is the same. That's true. Sorry about that. The minimum speed of the projectile is just after launch. That's not true. The x velocity of the projectile is unchanging. That's true. The acceleration for the projectile in both the x and y directions does not change. That's also true. In the x it's 0 and the y it's -10. So B is the right answer. Basketball is shot from a free throw range. At some point prior to the top of the basketball's trajectory, the acceleration is what? Well, the acceleration in the y direction is always the same. It's always -10, and in the x direction it's always 0. So let's see. Okay, so the answer here is going to be B, equal to the acceleration due to gravity, because the total acceleration is ax and ay. So since ax is 0, ay is the acceleration due to gravity. Consider projectiles that follow the path shown in this figure. Is it possible that all had the same initial speed? Yes, it is possible. They could all have had the same speed. It's just they would have had different angles. So for example, this one might have been 60, this one might have been 45, and this one might have been 30 degrees. But they could all have the same initial speed. Which of these represents the y component of the velocity for an object launched from the ground at an angle and returns to the same y position? Okay, I'm going to start at a big positive velocity, go to 0, and go to a big negative velocity. So A is the right answer. Has many forces on it, but the net force is 0, then the object will continue at constant velocity forever. If the net force is 0, that means that the acceleration is 0. It means the velocity is not changing. So it will continue at a constant velocity forever. None of these others. Two objects A and B experience the same net force. Object A has twice the mass of object B. Therefore, which of these? Well, object A, if it has twice the mass, is going to accelerate at a slower rate. F equals ma. So if I have twice the mass, I'm going to have half the acceleration. So object A will accelerate at 1/2 the rate. So 13 is D. Which of these are the basic SI units for force? Well, F equals ma. That's kilograms, meters per second squared. That's A. Which is another name for Newton's first law? Law of inertia. This is second law, this is the third law, and this is just made up. Two forces act on a body. One pushes to the north, one to the west. Which direction does the body accelerate? Okay, north, west, south, east. One force pushes in this direction, one in this direction. So the net direct force will be in that direction, which is C. Large truck runs into a small car, which exerts the larger force? Neither. They both exert the same force. That's an application of the third law. Force due to friction on an object is always opposes the direction of motion. A block with mass 5 kilograms moves on a flat surface. A force of 20 newtons causes the block to move with an acceleration of 2 meters per second squared. What is the coefficient of static? Excuse me, this should be kinetic friction. Kinetic friction for number 19. So what's happening here is I have an acceleration in this direction equal to 2, and I have a force equal to 20 newtons, and a mass of 5 kilograms. However, if I apply a force to 5 kilograms of that, I would get 4 meters per second squared. So I must have another force over here. And so I would figure out what that force is by saying the sum of the forces equals ma. That's 20 minus my kinetic friction equals 5 kilograms times my acceleration, which is 2. So that means that Fk equals 10 newtons. My normal force Fn is equal to the weight, which is 50 newtons, and so mu is going to be Fk over Fn, which is 10 over 50. That's 0.2 is the right answer for number 19. A woman who weighs 700 newtons steps onto a scale that is in an elevator and begins to accelerate. The woman now weighs 800 newtons. Okay, so if she's on a scale, if she weighs more, that means that it's accelerating upward. So I can get rid of this one and this one. It has to be one of these others. I can say the sum of the forces equals ma. So the sum of the forces is going to be Fw. And my Fn is what the scale reads. So I have Fn minus Fw equals ma. I want to know what the acceleration is. Fn is 800 newtons. Fw is 700 newtons. Divided by the mass, which is 70 kilograms. So that's 100 divided by 70, which is 1.4 meters per second squared upward. Let me show you where I got this mass. She weighs 700 newtons, so the mass is F over G, which is 700 over 10, which is 70 kilograms. This is from OpenStax. So I have this ship. It has thrusters on the back. Each thruster provides T thrust to give an acceleration with a resistive force F. I want to know the magnitude of T. So what I would say here is that a 4T minus F equals mass times acceleration. That's the sum of the forces equals ma. And then I solve for T. So T is F plus ma divided by 4. F is 420. M is 1200. A was 25. Divided by 4. I get 7,600. So A is the right answer. 2 kilogram block initially at rest moves in a horizontal direction with a force of 10 newtons. How far is it from the initial position after 4 seconds? Okay, so first find our acceleration. A equals F over m. That is 10 over 2, which equals 5 meters per second squared. That's our acceleration. I want to know the displacement. X is v naught t plus 1/2 at squared. It's initially at rest, so this goes away. 1/2 of 5, that's my acceleration due to this force, times 4 squared. So 8 times 5 should be 40 meters. D. Alright, 2 kilogram mass is pulled up an incline by a rope, so it accelerates at 1 meter per second squared. What is the tension in the rope? Okay, so there's Fw. There's Fn. Looks like there is no friction. It's smooth. Here's Ft. Okay, I'm just going to look at the forces in the x direction. So I have Ft. I have Fw cosine 60. I have Fn. And I have Fw sine 60. But it's accelerating only in the x direction, and I'm looking for Ft, so I say Fw cosine 60 minus Ft equals ma. I know all these things. That was 2 kilograms. That's 20 cosine 6, 20 newtons. 2 kilograms, 1 meter per second squared. We need to be careful because it's accelerating in the negative direction. So it's going to be Ft is going to equal 20 cosine 60. Should be 12, so it should be A. Is how much is that? 23. That's A. Be careful with your signs here. Make sure that you get the acceleration to be negative. All right, consider the block accelerating up the inclined plane. Which of the following equations is correct? So I have Fn minus Fw sine 30. I'm just going to write the forces here. Here's Fw, I have Fk, and I have Fn. If I draw my free body diagram, oh, I'm sorry, not that direction. Yes, it's moving up the inclined plane. So I have Fw cosine 60. And this is just F. It is moving up the inclined plane. Yes. Okay, so that's why my kinetic friction is in this direction, because it's moving up the inclined plane. Now let's look at these. Fn minus Fw sine 30 equals 0. That's not right. Look, it should be... Oh, actually, no, that is right. This should be, in both of these cases, should be 30 here and 30 here, because if this angle is 60, this angle is 30. So looks like this is correct. F minus Fk minus Fw cosine 30. Looks like that is correct too. F minus Fk minus Fw cosine 30. F minus Fw cosine 60 plus Fk. That one is not right. So 1 and 2 only for 24. 4 kilogram mass is pulled across the floor using a rope. The coefficient of kinetic friction is 0.5. What is the acceleration? So I have Fw, Fn, I have Fk, and then I also have this force broken into its components. So that's 50 sine of 30 and 50 cosine of 30. And now I want to know what the acceleration is. Well, I want to look at the sum of the forces in the x direction. That's 50 cosine 30 minus Fk equals max. This is what I want to know, but I don't know Fk, so I need to figure that out. In order to do that, I need to figure out the normal force first. So some of the forces in the y, that's 50 sine 30 plus Fn minus Fw equals 0. That's going to be Fn then will equal to Fw minus 50 sine of 30, which is equal to 40 minus 25, which is 15 newtons. So that's my normal force, and then my kinetic frictional force will equal to the coefficient, which is 0.5 times 15 newtons. That's my normal force, or 7.5 newtons. So now I can bring it up here. I get 50 cosine 30 minus 7.5 divided by my mass, which is 4. That should be my acceleration. Oh, I get 9. 8.95, or B for number 25.